What we're going to do here is look at an example out of our book and kind of step through that. And then we will go over and look at a CAD drawing of laying one of these out. So this example has numbers that are different from the assignments you will be drawing. He has some numbers and he says this crank AB is 1 inch long. This coupler BC is 2.5 inches long, and the rocker CD is 1 1/4 inches long. Now, if you made these out of pieces of cardboard or pieces of plywood or something, steel flat bars, they would be rigid, wouldn't they? These are not stretchy things. They are not going to change length. Whatever length this is, that's the length that will stay. So AB starts out 1 inch long. It's going to stay 1 inch long even while it's rotating around point A. So you could draw a circle centered on point A that would trace the path that point B is going to follow as that crank rotates around. And likewise over here, the rocker points bar CD, it's never going to change length. We don't know if it'll trace a full circle or just rock back and forth, but what we do know is point C out there at the end of that rocker is always going to lie somewhere on a circle that is 1 1/4 inches long, because CD is 1 1/4 inches long, and that circle will be stuck there at point D. It's going to be pivoting around D. So we could draw some circles that will show us where the paths of those two pins are going to have to be somewhere. It's all about circles. So here is crank AB. It's 1 inch long. And here is someone drawing a circular path with the center at A and the circumference at B, and the radius of that circle is 1 inch. Okay, now here is follower CD, and it's 1 1/4 inches, and here is someone drawing a circle with its center at D and its radius 1 1/4 inch long. So far, so good. Now what happens when this thing goes all the way as far as it can go? When these two links are stretched out straight, crank AB and connector BC, the farthest they could ever go to the right happens when they're stretched out in a straight line. Now we don't know what angle that is, but we do know they don't stretch. So that stretched out position is going to have to be what length? It's AB, which is 1 inch, plus BC, which is 2.5 inches. So this total stretched out length is going to have to be 1 plus 2.5. It's going to have to be 3.5 inches long. And so you can draw a circle with its center at A and a radius of 3.5 inches, and you can just draw a big old circle here. That's AB and BC in their stretched out position, and wherever that big old circle intersects the circle that you made with follower CD, that's got to be that farthest right position right there at that point. It can't go any farther because these things don't stretch. And if it goes back a shorter distance, well, then these won't be stretched out in a straight line anymore. Now, how about the very shortest position? If you were to make these bars for yourself out of pieces of cardboard or pieces of plywood or steel, and you pinned them with bolts or pivot points, you would discover that at some point BC, let me back up. So here's, AB, the crank. AB is going to swing off to the left. There's crank AB swinging off to the left, and the connector, the coupler BC, is going to fold up over the top of it. That's the very shortest that distance can be. And how far is that distance? Well, looking at this crude diagram I made, it looks like the distance is connector BC minus crank AB, so 2.5, the connector, minus 1, the crank, leaves 1.5. Somewhere 1.5 inches from pivot point A, somewhere along that circular path, 1.5 inches away, is where that pivot point C has to land. And so wherever this circle, this 1.5 radius circle, intersects the circle that you drew with the rocker, CD, at that intersection, that's where the far left-hand position has to land. It can't go any farther to the left because these are non-stretchy, and if it goes any farther to the right, well, these won't be folded up straight again. Now, if you needed to measure the angle, you could have your two extreme positions drawn right over the top of each other. Here's CD with its most stretched out to the right position. Here's CD with its folded up off to the left position. And now you could take AutoCAD's angle dimension and just measure how big is that angle. And that's what he asks you to do in problem 3. So let's look at these assignment problems just a little bit. Here's problem 1 that you will actually draw, and these numbers are different from the examples we just looked at. These are new numbers. And here are their lengths. So here's AB, it's 2.5 inches long. Here is CD, it's 1 3/4 inches long. And the connector between them, BC, is also 1 3/4. Here at the bottom of the slide are 2 different examples of what your answer might look like. I think these are both out of the textbook's solutions manual. Apparently he had 2 different people draw them. So either one of these would be correct. Looks like they're maybe scaled at different scales. His pins don't look like 3/32 relative to the other lengths. I think they're a little bit out of scale, but never mind that. It might look like this rocker CD is vertical, but it's not. Don't be misled by how that appears. It's actually not quite straight up and down. It's a little bit off, as you'll see when you get these all stretched out. So here is the same problem again, and I've labeled in the extreme right position, here is the stretched out length of the crank and the connector all stretched out together, AB plus BC. Then in the far leftmost position, here is the stretched out position, follower BC, follower CD and connector BC. And that's how far they can go when they're all stretched out. Here's problem 2. Similar idea. Here are two different versions of what your answer might look like. In all of these, you should make the two different positions in two different line types so that it's easy for you, the designer, or me, the reader, to tell, okay, these lines are supposed to be the right position and these lines are supposed to be the left position. And you can use whatever line type you prefer, just make them different. Here's what problem 3 will look like. Here are its dimensions. So stretched out all the way to the right, and then stretched out all the way to the left. And here is the angle that he's asking you to dimension. This is the one that I'm pretty sure is 86 degrees. And I have a handout for you, a PDF that steps you through how to lay these out.